Now that you've worked with piecewise functions a little bit and have seen the application problem as well as the Desmos activity, let's continue basically digging a little deeper into some things we can do with piecewise functions. Normally, the first thing that we do is go through an exercise called evaluating. Now, evaluating is really just a fancy word for plug a number in, and get a value. Except what we want to realize is that whenever you do this for a piecewise function, you only ever plug in to one of the pieces, to one of the equations. So f of 0. F of 0 definitely implies that we want to plug in 0. What we want to do is we want to realize that only one of these pieces can work for numbers like 0. So what kind of number is 0? Is 0 a number that's greater than 10? No, 0 is not a number that's greater than 10, so I'm not going to plug into that piece. Is 0 a number that's less than -2? No, 0 is not a number less than -2, so I won't plug in there. Is 0 a number that is between -2 and 10? Yes. Now, because the answer is yes, I'm going to plug into this piece. But this piece is interesting because it's a constant. What that means is that it's constantly equal to 6. So when I quote plug in 0, although there's nowhere really to plug it in, my output, my value, is going to be 6. How about 14? What type of number is 14? Is 14 a number that's greater than 10? Well, actually, yeah, 14 is a number that's greater than 10. So what that means is I'm going to plug into the x minus 5 piece. How do I plug in? Well, you know how. You just plug a 14 in there for x. Of course, that's going to give you 14 minus 5. Now, 14 minus 5 is equal to 9, and that is our value when x equals 14. How about -6? How about -6? What type of number is -6? Is -6 a number that's greater than 10? No, -6 is not greater than 10. Is -6 between -2 and 10? No, but -6 is a number that's less than -2. What that means is that I plug into the -x² piece. Now, when I plug into the -x² piece, I do need to be careful, mainly because there's a negative sign and because there's the square sign, so I've got to be careful about my math. Basically, my math, or my order of operations, says that you need to do the exponent first. And notice that what I'm trying to insinuate here is that the exponent is only on the -6. So what's -6 squared? Well, of course, it's positive 36. But you see, there's still a negative sign that's been out front of this equation from the beginning. And that negative sign is going to ultimately switch my sign, or switch my 36 to be a -36. Okay, but the whole point is that I only plugged into one of the pieces. I plugged into the last piece. How about the number 10? Where are you going to plug in the number 10? We want to do f of 10. Now, is 10 greater than 10? No, it is not, but it is equal to 10. What that means is that I'm going to plug into this piece again, this middle piece, which, as we said, is always equal to 6. Excuse me. I got a tickle in my nose. What do you think? Do you think you can evaluate a piecewise function? We want to do f of -1. We want to do f of 3. where are you going to plug in -1, and where are you going to plug in 3? Excuse me. Now you should be thinking, what type of number is -1? Is -1 a number that's less than 0? Well, by golly, it is. So that means we're going to plug -1 in here for x, of course, into this first piece. Now when you do that, again, you want to be very careful about the order of operations. You want to be very careful about plugging -1 in there for x. You should be doing the exponent first. You want to do the exponent first. That means you're going to square -1. That actually just comes out to be 1. Notice I haven't done anything with the number 3 yet, but now I can multiply by 3 and add 1. Well, when you do all that, you get 4. What type of number is 3? What type of number is 3? It's a number greater than 0. But that means I'm going to be plugging into the 5x minus 2 piece. A little bit easier to plug that in. You're just going to multiply by 5 times 3 and subtract 2. And that should be coming out to be 13. Evaluating a piecewise function. Basically, you're just plugging in to the correct piece. Now for some of the good stuff. The good stuff. Graphing a piecewise function. Now, it is definitely true that graphing can be a challenging concept. And now we're going to be graphing pieces of functions. Let's get some thoughts so that we can try to be successful with this, of course, as successful as possible. First of all, you're going to find me usually lightly sketching the entire graph. Even though it's going to be a piece of a graph that I want, I'm still going to graph the entire graph to help us represent the equation. Now, the endpoints can be used to understand the beginning and end. And the domain restriction is going to help us to get those endpoints, which, as you're going to find out, help us to finalize the appropriate piece of the full graph. Let's give it a try. Okay, we're going to graph the piecewise function 3 minus x for x values that are less than or equal to -1. And then we're going to graph -1 for x values greater than 2. First thing you want to realize is that 3 minus x is actually a full line. It's actually a full equation. Maybe to help describe it a little bit, we could rewrite it in the mx plus b format. If it helps you, we can rewrite it as y equals -x plus 3. It's still the same equation. We just put the x first, and we put the 3 second. Now, this type of equation is an equation that has a y-intercept of 3, and it has a negative slope. Of course, that negative slope means I go down 1 and over 1, but I can also go backwards a few notches if I want. And what you're seeing me do right now is lightly sketch the entire graph. I'm getting an idea of what the entire graph would look like that starts at 3 and has a negative slope. Next, I'm going to think about endpoints. Now, this is a very important part of the problem, so watch carefully. We're going to take this -1, which you should feel like is the endpoint or the beginning point of this piece, and we're going to plug it in. Now when I plug it in, I get 3 minus -1. Be careful about that math. That actually comes out to be the number 4. But what does that mean? Well, that means that -1, or I should say when x equals -1, y equals 4. We call that a point. We call that the starting point. And that point is right here. Now, maybe you want to highlight it, maybe you want to focus on it. The bottom line is that that's going to be the point where this graph starts. So where does it go? Where do we go after -1, 4? By the way, normally we will label that point. So, excuse me a second here. I'm going to label -1, 4 just with the actual values. Okay, that way when I erase it here, I haven't forgotten it. Now, which way do we go? Which way are x values that are less than -1? When you see the less than symbol, you want to think left. Less than means left. What kinds of x values, or should I say, where are the x values that are to the left of this starting point? Yes, that is correct. They have to be the x values that go this way. And so when it's time to draw my graph, I actually am going to draw the piece of the graph that is going less than -1. Again, to the left of -1. What about the rest of these points that I kind of graphed here? Well, they should be erased because now I have my first piece of this piecewise function. To review, we started the problem by thinking about the full graph of 3 minus x. And 3 minus x is really y equals -x plus 3, to kind of write it a little more in the normal order. I thought about the full graph of that line, and ultimately I only graph the part that is less than means left, of my starting point. And that's the piece that you see graphed here. Let's try the second piece. Now, the second piece is rather interesting because the equation is nothing more than a number. When you graph an equation that's a number, you can still think of it as y equals, if that helps you, but you're just going to end up with a horizontal line. A horizontal line that always has a y value of -1. And as you can see, what I'm doing is lightly sketching the entire horizontal line represented by -1 until I dig a little deeper and think about my endpoint. Now, normally you take your endpoint and you plug it in, but there's nowhere really to plug in to, because the output is always going to be -1. So instead, what I can do is I can just realize that, hey, x equals 2 will be my x value, -1, that is this -1, will be my y value. In other words, the point 2, -1 is my starting point to this graph. Now I can highlight that point, I can kind of focus on it. That's going to be where this piece is going to start. So where do I go? Oh, forgive me. We should label that point. Honestly, I always want you to label with numbers the endpoint or the starting point of your graph. So there we go. We got 2, -1. Now, which side of the graph do I ultimately use for my piece? Well, the answer is which side is represented by x values greater than 2. Greater than means to the right. So from my starting point here, I want to now graph, I want to use the points that were to the right, again, of 2. To the right of x equals 2. which means that I'll erase those other points that I lightly shaded, and now I have my other piece. Almost. There's one small detail. It says x is greater than 2. It doesn't say that it's equal to 2. What I'm implying there is that we should represent an open circle. We should be representing with an open circle this starting point. And so I'll kind of open it up, or if you have to, you can erase and just draw an open circle around the point 2, -1. That's kind of a different looking piecewise function. You might be saying that the two pieces do not connect. You're correct. They do not connect. That's okay. But let's try another one. Let's try another one. First thing to do, try to graph the whole piece, the whole equation, y equals x plus 2. Now, y equals x plus 2, that's right. It's going to be a graph that starts at 2. It's going to be a graph that starts at 2 and has a slope of 1. Of course, if I have a slope of 1, I'll go up 1 and over 1. But I can also go backwards so that I can kind of see that entire line. Remember, plugging in this endpoint perhaps might be the most important point. When I plug in -1 to this equation, I get 1. Well, what you're really talking about is when x equals -1, y equals 1. That, ladies and gentlemen, is my starting point. Where is that starting point? That's right, it's right here. It's the point -1, 1. Now, I can highlight that point, I can make it a little bigger, but that's going to be the place where my graph is going to start. And ultimately, I want to now select the part of the line that's less than -1. Less than means left of -1. To be left of this point is to go in this direction, to go left, which means that the rest of my graph I really don't need, and so we will erase. What's that you say? It's just less than and not equal to? You're correct, which means that I do need to open up this circle. We need it to be an open circle to represent just being less than. Let's graph -x, or sometimes thought of as y equals -x. What kind of graph is that? Well, remember, it's a graph that has a y-intercept of 0, since that's not shown. So I'm going to start at 0, and then it has a negative slope. If it has a negative slope, I go down 1 and over 1. I can also go backwards a couple steps, just to kind of get an idea of what that entire line looks like. Ultimately, it's going to be the endpoint that's the most important point. So you take -1 and you plug it in for x. Now be careful, when you do that, you actually get a double negative. You get the opposite of -1, which is 1. What you're really talking about is the point -1, 1. Wait a minute. We just talked about that point. That's right. This purple line is going to pick up where the red line left off, which means we're going to now select the part of the graph that is greater than -1. Now remember, greater than means to the right of this point. I'm talking about this point, this starting point. Yes, that's right. If you go to the right of that point, you're actually going here. You really want to still feel like that's a greater than, because greater than means to the right. Don't worry that the graph happens to be going downwards. That's just because of the slope. So, this piecewise function actually connects. And by the way, I end up filling in the circle because of the equal to That was part of my greater than sign. So I end up with a graph, a piecewise function that is comprised of these two graphs both put together. Normally, at this point, I would say to any student in the classroom, you try. You try example 5. You try to graph 2x for x is less than 0. You try to graph x plus 3 for x is greater than 2. Now, I am going to go over it, but when you're watching these videos, you need to be disciplined enough to pause the video so that you get an opportunity to try. So, did you pause the video yet? All right, so how did you do? We're going to try to graph the equation y equals 2x. Now, the equation y equals 2x starts at 0. It has a slope of 2, which means I go up 2 and over 1. I can also go down, if you will, back the other direction to help me kind of see the entire line. Now, I should be plugging in this endpoint, although that might be kind of easy to see that when you plug in the endpoint, you just end up getting 0. That is the point 0, 0. Now, the point 0, 0 is a big part of this graph because it's like the starting point. It's the starting point. All I have to do now is think which way is less. Less means left, so I want to grab the left side of this graph. Yes, that's this side right here, as I actually create my first piece. Now, it was just a plain less than, so that means that, as we've done before, this actually should be like an open circle here. What's going on? There we go. We got an open circle around the point 0, 0. Yes, we should be labeling that point, so I'm going to write 0, 0 beside this. I always want you to label your starting points or your end points. Just erase the rest of your graph, and we're ready for the second piece. The piece represented by y equals x plus 3 would start at 3 and have a slope of 1. I can also go back the other direction just so I kind of see the whole graph, because you never know which side you're actually going to use for your final answer. Now you want to plug in 2. That helps to get your endpoint, right? That helps get your endpoint. Or in this case, maybe you rather think of it as a starting point. That starting point is right here at 2, 5. Let's get that labeled. I always want you to label your starting point and end point. So what do we have here? We have a greater than sign. Greater than means to the right. Which side of the graph is to the right of this point? That's correct. It's going this direction, to the right. So that's the part of the graph that I ultimately will draw. Yep, it's just a greater than, not an equal to. So once again, we need to have an open circle here. The rest of these dots, the rest of this lightly shaded graph, we can get rid of. And so our final answer looks like 2 lines, one of them pointing less than 0, that's to the left of 0, and the other one pointing greater than 2. How about this last example? It's kind of special. It looks like just a bunch of numbers. Okay, well, what you want to still do is keep in mind that these numbers, for example, the number 1, is really the graph y equals 1. Now, the graph y equals 1 would be like a horizontal line. If I was going to lightly shade it, it would be that horizontal line. except I only want that horizontal line for x values that are between 0 and 1. Now, x values that are between 0 and 1 actually is just this small space right here. So let's get rid of most of this graph. It's a little too much to look at. There we go. Let me get rid of that. I'm only going to graph the line, the horizontal line 1, between 0 and 1. And specifically, I have an open circle at the end, but I have a closed circle at the beginning. And I just graphed my first little piece. Well, this fun stuff is going to continue for a few more numbers, right? A few more lines, like the line y equals 2. Y equals 2 is actually a horizontal line up at 2. But I don't need that entire horizontal line. I only need that line for numbers that are between 1 and 2. Where are x values that are between 1 and 2? That's right, they're right here. A closed circle at the beginning, an open circle at the end. What's happening here is we're creating what's called a step function. A step function is literally a function that steps from y value to y value. And I can quickly finish this pattern as I graph 4 horizontal lines, each of them only between a small portion of x values. All right, so that would be your final graph of that step function. Now, your homework is actually on a separate sheet of paper just because I didn't have enough space. So find that half sheet homework. Either it was handed out in class, or you can get the digital copy off today's calendar link. And I'd like you to try working on those piecewise functions, which match, of course, with today's lesson.